Hi, and welcome to Acronis, our information security series. Today we're going to be talking about distributed denial of service. We'll be first saying, what is distributed denial of service, or DDoS? How does it work? Common types of DDoS attacks, concerns for service providers, and tips for mitigating DDoS attacks. My name is Steve Brining. I'm a partner technology evangelist here at Acronis for about 4 years in our cyber protect side. Been in the industry for over 25 years, mostly on the manufacturing side in cybersecurity space. So a distributed denial of service attack is an attempt to disrupt normal traffic or targeted server services or networks maliciously, floods internet traffic to a target or infrastructure around it. It's used to compromise systems as a source of attack traffic, and this includes computers or other network resources like IoT or Internet of Things. The analogy I like to use is, think of some unexpected traffic jam clogging the highway, which prevents regular traffic from arriving at its destination. So how does it work? Well, computers and other devices like IoTs get infected with malware. This allows an attacker to remotely control them, and they're called bots or zombies. And then if you take a group of these computers or IoT devices, then they're called a botnet. The botnet, once established, the cybercriminal then directs attacks, sending remote instructions to each bot. Each bot then sends a request to an IP address of a target machine to overwhelm the service or network. The result of that, denial of service from normal traffic. Each bot's a legitimate device on the internet, so separating attack traffic from normal traffic can be challenging. At the end of the day, it's multiple systems taking part in an attack simultaneously. How do you identify this? Well, a service or site can get slow or unavailable. Now, there could be some legitimate spike in traffic to create some challenge, so you need to investigate a little further. An example would be a software company where you release a major version of a product. There might be some spike in the internet traffic after the release. There could be an unexplained surge in requests to some endpoint or single page. Or there could be odd traffic patterns. Are there spikes at odd hours of the day or some unnatural pattern? Say, are you having spikes every 15 minutes? Now, there's common types of DDoS attacks. The OSI model, otherwise known as the Open Systems Interconnection model, there are 7 layers, and there's 3 main categories of attacks here. So we're going to discuss these on the next series of slides. The first is an application, or at the layer 7, as you see, floods applications with malicious requests, and this is measured in requests per second. It is challenging to defend because it's hard to differentiate malicious to legitimate traffic. So an HTTP flood is like hitting the refresh on a web browser over and over and over again on many computers, all at the same time. Now there's protocol or network attacks, and this affects the 3rd and 4th layer in the OSI model. It's to overconsume server resources or network equipment like firewalls and load balancers with large number of packets, and this is measured in packets per second, and you'll see something called SYN floods. Now, SYNs target TCPs, or transmission control protocol servers, like web servers and email servers. And there's a 3-way handshake that's needed here. So think you have a client and a server. Well, the client needs to send something called a SYN message. And that's a synchronized message saying, hey, hi, I'd like to sync up with you. Then the server has to then say, yes, you can sync with me, but I'm also acknowledging this with you. Client further then has to confirm the connection with a final acknowledgement message. Well, then a TCP SYN flood is when the system is flooded with all those SYN requests there in the red, and it overwhelms the target, making it unable to respond to new real connection requests. So once you have this 3-way connection, the communication does get established. But like I said, there's so many SYN floods going there that it can't respond to new real connections. And then finally, there's volume-based, which is massive bogus traffic to overwhelm a resource, a server or website. And this is measured in bits per second. Concerns for service providers. There's distributed denial of service, booter services. They're on-demand DDoS attack services. These reasons can range from folks trying to increase their hacking skills, business rivalries, extortion, government-sponsored terrorism, to ideological conflicts. Now, a competitor with not many skills can employ scripts or programs written by others to launch this attack on you as a competitor. Since they don't know how to do much, we call them script kiddies or skiddies. Now, I know there's one service out there that has different levels of intensity and length for the DDoS attack, and these range, well, I've seen it from like $20 to $150, and what's interesting, they even offer 24/7 support. Now, in 2019, there was relatively a small amount of DDoS attacks. Well, at the end of 2020, there was a massive uptick in attacks. There's something called RDDoS attacks, and that's a threat of a DDoS attack unless a ransom gets paid. So they target victims that are less able to respond and recover from such an item. Concern not on an attack on your business, but you have to think about attacks on your business partners, vendors, suppliers, and whatever your business relies on. What is the goal? You want to differentiate normal and attack type traffic in order to help mitigate these DDoS attacks. The more complex the attack, the harder to decipher normal versus attack traffic. Dropping or limiting traffic could throw out good stuff with the bad. So there's a layering ideal solution here. Rate limiting. This is good for web scrapers, stealing content, and brute force login attempts. By itself, it's not sufficient enough to handle a complex DDoS attack. Web app firewalls. This will help with layer 7 that we were discussing earlier. This is between the internet and the server. You filter requests based on a series of rules. You could do something called an Anycast network, where this scatters attack traffic across the network or distributed servers to a point where the traffic gets absorbed by the network. Well, this is going to depend on the size of the attack as well as the size and efficiency of your network. Do you have some kind of DDoS mitigation plan ready? Have you thought about a disaster recovery plan and testing procedures? Now, keep in mind, attackers will watch how sites respond, and when you're back online, they'll adjust with the new attack method, so you got to make real-time adjustments. Think of having DDoS protection plan and mitigation services. I can't recommend one for you here, but just Google and you can see that there's many companies out there that provide that. Combat application layer attacks inline. There's web protection tools, add redundancy to an application, deploy to multiple public cloud providers. Also, look for secondary attacks. DDoSes can be a distraction for another attack. Have you reset factory preset passwords on anything that's connected to the internet? Have you gotten rid of the admin? And disable things that you don't really need. And finally, do you have firewalls installed on a server? Are security patches up to date? Is your antivirus and malware software running on a schedule? And also regularly monitor system logs. And with that, I want to thank you today. Hope this helps you with DDoS attacks, understanding them, and tips for mitigating them.